Hello and welcome to our next lesson here in Pre-AP Pre. Just wanted to give you a heads up as to where we're at currently in the course. Last class we covered section 1.3 of our textbook, which dealt with parent functions, what it means to be an even or an odd function, and how to identify that. And section 1.4 of our textbook I actually skip. I typically don't cover it. It has to do with the transformations of a function. The reason for not covering that is if you're watching this video, the course that I teach is pre-cal, so by this point, I'm confident that you cover that material in Algebra 2, and I actually hit that material later on in the year in my class, okay? So we're going to move on to 1.5, which is titled Combination of Functions. And the word combination is literally what it sounds. So you're going to combine functions, okay? So think about it. In the past, like if I gave you numbers and I asked you to combine them, the way that you can combine numbers is by using operations such as addition, subtraction, multiplication, and division. So if you can do it with numbers, you should be able to do it with functions, and that's exactly what happens, okay? So we can use the operations to combine functions, so you can have addition, subtraction, multiplication, division, okay? So the way that you read the statements, it says f plus g of x, f minus g of x, f times g of x, f divided by g of x. But literally what those things means, guys, is that you take one function and you add the other, or you subtract it, or you multiply it, or you divide it. And there's one thing especially to denote with division, and you should already know this, is that you cannot divide by 0. So the way that I wrote this means that g of x could not possibly be 0, okay? One of the things that you are going to encounter in this video is that I will ask you about the domain. So my assumption is that you know how to find domain, so I'm not necessarily going to cover that topic of how to find domain. But I am going to ask you to find it. I'll give you a few tips, okay? So if you really are learning domain for the first time, I would recommend that you actually do a Google search or a YouTube search for how to find domain and range of functions, okay? Now, one thing about this, and the reason why I bring it up, is that when you combine functions, the domain of that result is going to be different. So the domain of the result would have to be the overlapping x values of the domain of the f function with the domain of the g function, okay? So that can be a little confusing to understand. So the best way to attack this problem, in my opinion, would be to actually try out an example in which we are going to perform all four operations and we're going to find the domain for that function, okay? So let's go ahead and give it a go. Let's try out an example. So let's say that we have the following functions. F of x is equal to x cubed plus 2x squared, and g of x is equal to 3x squared minus 1. Okay? So at this point, if you feel like you're capable of doing this, I would like you to pause the video and I want you to go ahead and find out 4 things for me. I want you to figure out what f plus g is equal to, what f minus g is equal to, what f times g is equal to, and what f divided by g is equal to. So go ahead and take a moment, pause the video, see if you can try it on your own, and then when you're ready to go over it, just go ahead and hit play again. Alright, so we're going to go ahead and go over it. I'm assuming you gave it a try. So this simply just means that we're going to take the f function, which in our case is x to the third plus 2x squared, and we are going to add the g function, which in this case is 3x squared minus 1. So all we're going to do is then follow order of operations and combine like terms. So I don't have another cubic term, so I'm going to have a cubic term there. I have an 2x squares here, and I have 3x squared, so when I add them, that becomes 5x squared. And then I only have a negative 1. So therefore, the solution for the addition of f plus g is just going to be x cubed plus 5x squared minus 1. Simple enough, hopefully. For subtraction, it's going to be very similar. So I still have the same order, except that this time I will be subtracting. One thing to recognize is I hope you notice that I am using parentheses to put my functions inside of. And the reason why I like to do that is for addition is not a big deal, guys, but for subtraction, a lot of students typically forget that when you're subtracting, you're going to have to distribute that negative to both terms there because it is going to affect them. So now that I've told you so, hopefully this will help you stay organized. So use parentheses, guys. So I have an x cubed. I have nothing that I can take away from it, so it's going to stay as an x cubed. Now I have a 2x squared, but I'm subtracting a 3x squared, so that's going to give me a negative x squared. And then I don't have a constant here, but I am subtracting a negative 1, so minus a negative 1 would give me a plus 1. So that will be the result for the addition of the two. The next one is we're going to try multiplication. So we're going to go ahead and take x to the third power plus 2x squared multiplied by 3x squared minus 1. And with multiplication, remember, you just have to distribute every term. So some of you guys use the term FOIL, which it's fine if you use it, but really the mathematical term for this is called distribution. So we're going to go ahead and distribute everything out. So we have an x cubed times a 3x squared. That's going to give us a 3x to the fifth power. An x cubed times a negative 1 will give us a negative x cubed. A 2x squared times a 3x squared will give us a positive 6x to the fourth power. And a 2x squared minus 1 will give us a 2x squared times a negative 1 will give us a negative 2x squared. I'm going to go ahead and say that there's nothing to combine. Some people would like to rewrite this statement in order from highest to lowest degree. You don't really have to. I would accept this answer if you decide to leave it like that. But you're more than welcome to rewrite it in order if you want to. Okay? And then lastly, we have a division here. So for our division, we're going to go ahead and take our f function, which in our case is x to the third plus 2x squared. And we're going to divide it by 3x squared minus 1. Now, with division, hopefully you can remember back to algebra 2. In order to divide, you're going to try to factor things out, and if anything cancels out from both the numerator and denominator, you can cancel out those terms. I can already tell that it's not going to happen here, but let's go ahead and give it a shot and pretend that we don't know that. The only thing that we have in common between an x cubed and a 2x squared would be an x, which would leave us with an x squared plus 2x. I'm sorry, plus 2. Yes, 2. Actually, I can pull out an x squared. I'm sorry. So let me go ahead and correct this over here. If I can pull out a x squared, then I would only be left with an x here and a plus 2. So that would give us x cubed plus 2x squared. And here, this is not a perfect square. So some of you guys, I'm going to go ahead and do it. I honestly wouldn't encourage you to do it. So this is a perfect difference of squares. We can technically, right, factor that out. But to be completely honest with you, it should be relatively obvious right now that it is not going to happen. This would be root 3x plus 1 times root 3x minus 1. Okay? None of this cancels, so technically, I mean, all of this work was kind of irrelevant. I would go ahead and say, okay, none of this really canceled out, so I can be fairly certain to say that the answer can just be left written that way. Okay? All right. So the operation part, hopefully you found it not to be very difficult. So now let's talk about the domain for all of them, okay? So what I recommend here is, first of all, to find the domain of the original two functions, okay? Now, back in algebra 2, you talked about polynomials and how to find the domain of a polynomial. Well, you should have learned that polynomials are continuous on an entire interval. So the domain for both of these functions is going to be the set of all real numbers. Okay. Now, because the domain of this is all real numbers and the domain of this is all real numbers, when you add them, you ask yourself, well, what numbers overlap between the two? Well, because it's all real numbers, then all of them overlap. So therefore, for addition and subtraction and multiplication, the domain is going to be all real numbers. So the domain for all three here is going to be all real numbers. Okay. Now, technically, you are going to be tempted to say the same thing for division, right? Because, well, you know, if the domain of these two are all real numbers, that means that everything overlaps, so this should be good to go. However, remember, when you're dividing, you cannot divide by 0. So because of that, I know that the domain of each one is all real numbers. We still have to consider that the denominator cannot be equal to 0. So what we're going to do is we're going to set that denominator equal to 0. So we're going to say 3x squared minus 1 equal to 0, which would then give us an x squared equals to 1/3, which would give us x is equal to plus or minus the square root of 1/3. Which, I mean, you're welcome to clean this up if you want to. So this technically gives us plus or minus. The square root of 1 is 1, square root of 3 is square root of 3. So that gives us the square root of 3 over 3. So if you want to write down the domain for this one, we would say the domain for the division one would be the set of all real numbers such that x cannot equal plus or minus square root of 3 over 3. Okay? All right, I'm going to do just one more example of this, this type of problem, and then we're going to go ahead and move on to something else. Okay? Now, let's say that you have the following functions. F of x equals the square root of 3 minus x. And let's say that you have g of x equaling the square root of x squared minus 1. Okay, so at this point, we're not going to do all 4: addition, subtraction, multiplication, and division. Let's just say that I want you to do, I don't know, multiplication. So go ahead and pause the video, give this problem a shot, do the multiplication, and find its domain. Okay, I'm assuming you gave it a go. So at this point, you're going to take your f function and your g function, and you are going to multiply them. So when you have square roots, so we have square root of 3 minus x times the square root of x squared minus 1. You are going to, because they are the same root, you can go ahead and multiply what's on the inside of that function. So this becomes the square root of 3 minus x times x squared minus 1. So I'm going to go ahead and clean that up a little bit more. So I'm going to distribute this out. This gives us a 3x squared minus 3 minus x cubed plus x, which then would, if I write it down in order for this one from highest to lowest degree, it would give me that. So the multiplication of these two functions would give me that result there. And that should be the answer for the combination of the two. So the question now becomes is, what is the domain of this? So remember, the trick is to first find the domain of each one individually. So right here, the domain for this function, based on what we have here, would be, okay, so we know that the square root function is typically 0 to infinity. However, we know that this function right here got moved or reflected over the y-axis, and it got moved to the left 3. I'm sorry, to the right 3 units. So that means that the domain for this function should be equal to negative infinity to 3. So yes, I'm sorry, not to the left, to the right 3. Okay. Now for this one, okay, so remember, this one's a little bit tougher because you've got a little bit more going on. So another way that you can find the domain is to set this equal to 0. So you got x squared minus 1 equal to 0. You're going to add the 1 and take the square root of that, so that gives you x equals plus or minus 1. So think this through. You can only plug in values between negative 1 and 1 that is going to give you an actual result out of that. So the domain for this would have to be from negative 1 to 1. Okay, go ahead and explain that. I'm sorry, not between negative 1 and 1. My apologies. Look at the expression. Now, these numbers are important for us to recognize. Notice that if we use positive 1 or negative 1, we would get a 0. Is the square root of 0 okay to do? Yes, absolutely it is. Okay, now think this through. Okay, so now you got to ask a couple of questions. What if the number is bigger than 1? So that would be a 2. 2 squared is 4 minus 1 is 3, so that'll give you a square root of 3, which is possible. So that means that anything bigger than 1 is going to work. What about anything smaller than negative 1? Negative 2 would be smaller than negative 1. Negative 2 squared is positive 4, minus 1 is 3, square root of 3 is also possible, so that means that anything smaller than negative 1 will also work. However, think about like if you plug in 0. 0 square root would be 0, minus 1 is negative 1. Square root of negative 1 is not a real number, therefore anything between negative 1 and 1 is not going to work, so it's going to be the opposite of what I said here. The domain for this is going to be from negative infinity to negative 1, and from 1 to positive infinity. Okay? So now that you know the domains of each one of them individually, remember, to find the domain of the overlapping, or the combination in this case, we want to know what values overlap. So notice how both of them have a negative infinity, so I can go ahead and say the domain is going to definitely include negative infinity. Now this one goes all the way to 3, but this one goes all the way to negative 1, which means that I cannot include 0, 1, 2, and 3, or maybe I can because it is part of this one, right? So think it through. I can go all the way to negative 1, but I'm going to have to stop there. I can pick it up back up at 1. And then I keep going to infinity for this one, but this one stops at 3, so that means if I can pick it back up at 1, I can only go as far as 3. So those are the values that overlap between the two, so that's the reason why the domain for the actual combination would have to be equal to this. Okay? All right. Hopefully this helps you out with doing combination of functions such as addition, subtraction, multiplication, and division. There is actually another type of combination of functions which is called composite functions, which I will be creating a separate video for that. Okay, so for now that is all for this short lesson, and stay tuned for my next video so that you can learn how to deal with composite functions.